Hello, welcome to how to learn how to calculate the sum of arithmetic sequences, or arithmetic sequences, however you would like to call it. In this video, I will teach you how to do it. But firstly, before we analyze and calculate, let us see what it actually means by the sum. When you identify the word the sum, you identify it notably with the symbol of plus or addition. Such like a question where it says sum of, for example, 5 and 3. That would equal to 5 plus 3 is equal to 8. And of course, it can also be denoted by this symbol. I'm not too sure. I don't know how to draw it correctly. It's like a backwards E. And that also represents the word of sum. When you do that, you add, it basically means to add everything. So when we have, say for here, question 1, sum of 25. So the sum of 25, and it's written as like this, but in text form, it can only be written like that for now. But you write this when you're in like writing for the question. This means the sum of 25. Now, what does it mean by 25? Well, let's go for a more simple pace, and let's quickly write down a simple arithmetic sequence: 1, 2, 3, 4, and 5. Now, what does it mean? If I were to say the sum of 5, well, what would that mean? So, as you already identified, this is the first term in the sequence, the second term, the third term, the fourth term, and the fifth term. Now, the sum of the fifth of the 5, what does that mean? Well, actually, this translates to the sum of the first n numbers. So for this example, we have 5 for n, because the equation is written at like Sn, and we replace n because it is a replaceable variable that changes. So what this means is, by reading the S and the 5 here, it means the sum of the first 5 numbers. Actually, I think a better way to say it would be the first 5 terms. Not numbers, sorry. So, as you identified, the sum is adding everything. And if you want to add the first 5 numbers, this is the first number, second, third, fourth, and fifth. These are the first 5 numbers of the sequence. So, you add them. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. And 10 plus 5 is 15. And so, the sum of the first n terms, or the sum of the first 5 terms, is equal to 15. So it's really simple. You add it. Now let me demonstrate you, I believe, 2 equations which you need to remember and are applicable to various aspects. Now for this video, we will only be focusing on one main primary equation, or formula, whatever you would like to call it, and it is Sn, the sum of the first n terms, is equal to n, which is replaceable or substituted for this case, t of n. So if we would say n is equal to 5, you would substitute 5 here, 5 here, and 5 here. Be sure to note that. Plus the first term, and everything is divided by 2. So following the rules of Bindas, this is a bracket, so we do brackets first. There's no powers, so no indices or powers. There's a multiplication after you add these in the bracket, so n times the inside, so that's a multiply. And then there is a divide, and there are no additions or subtractions in this equation. So you do the brackets, the inside of the brackets, and you add those first. And then you do the multiplication. So actually there is addition, in a way, when you add the 2 numbers in the brackets, but let's not think about that. You times, and then you divide by 2, and that is your sum. So, let's just get rid of all that stuff, and let's start using this equation. And I'll talk about the other equation that we would use, but it's not used frequently. And the differences between the two equations, which I will talk about later, but also a bit now, is that this equation here works for if you have a arithmetic sequence that you know the last term of. So for example, our first equation, or first arithmetic sequence, sorry, has a last number, and that is 17. Now how do you know that is the last number in the sequence, or last term in the sequence, sorry? Well, because it ends off with 17 and it does not continue. And then how do you identify if it doesn't have an end term? Well, if it doesn't have an end term, sorry, it would end off as comma dot dot dot, or just go with dot 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 ellipsis to identify that yes, it goes on. And so then you would use the second equation. But this equation that we're doing right now, or formula, is for purposely for if you know the last term. If you know the last term of sequence. So that is what it is. If you know the last term of the sequence, which is 17, there's no ellipsis right after, that is the last sequence, and you can use this formula for that. There are also other circumstances where it might seem that you don't use this formula and you use the other formula, but this formula works most of the times. But if it doesn't, then you can use the other formula, which is still very useful. I just have a bias likelihood, well, not likelihood, I just really love this formula way more than the other one. But let's just shrink it a bit, and let's just keep it up here right next to here, just so we can refer back to it if you ever need to, and you just can't remember. And so, let us begin calculating. And so we have our first question here, and that is, find the sum of 25, or the sum of the first 25 terms. So, this is arithmetic sequences that they've given us. They give us D because it goes plus 4, and that's the common difference from each term. And they give us the first term, second, third, and fourth, and fifth. But what we really want is the first, really. So, when you look at the equation here, right? Sn equals n bracket Tn plus T1 over 2. What you can firstly notice is you can easily get this n value and this n value, and this is what you're trying to find, so you don't need to worry too much about it. But when you replace n with a specific value of t of n, and for this sake, n is 25, so S25 is equal to 25 times t, the 25th term. That means that you have to find the 25th term. Now, as you can see, they haven't given us the 25th term. They've just given us the first term and the common difference. And voila, if you think about it, there's an equation for it. Tn equals T1 plus D bracket n take 1. So, since we need to find the 25th term to put into the equation or formula to find the sum of 25, let us begin solving the 25th term. That way we can solve the sum of 25. So, t, remember n, we're going to substitute n for 25, so we can find the 25th term. T25 equals T1, which is 1, plus 4, because it goes in 4 each time, so 4. Bracket n, which is 25, take 1 is 24. And so I'll just quickly, 24 times that, 16, 96. And that will equal to 97. So the 25th term is equal to 97. So you always gotta write down what you have. So like they've given you T1 equals 1, they're giving you D equals 4. And we want to find the sum now, since we know all of the things for this formula. We know n, which is 25. This is also 25 here. So remember, we can substitute n for 25, so this would be sum of 25 equals 25 times the 25th term, and we've identified that the 25th term is 97. So we can input that, 97 plus T1, which is 1, so it's 98. So, all we do is we just put that in. So let's do it. The sum of 25 is equal to 25. So you can just refer to that formula now. Brackets Tn, which is the 25th term, T25, 97, plus T1, T1 is 1, plus 1, divide by 2, so everything's divided by 2. And following the BIMDAS rules, we do the brackets first, so let's do that. Portion to portion, 98. You add those, it becomes 98. You times to 25, multiply. So let's just quickly do that. 40, 45, 49, 16, and 18 is equal to 0, and that is a 15 carries on to here. 8 plus 4 is 12, that's 13. 13 carries on is 2350. And that's just simple double digit multiplication. So it equals to 2,350, sorry. And remember, so we just did all of this. So let's just simplify it. It's 98. 20 times that and equals 2,350, but you have to divide by 2, remember? That equals 2. Or not square root, but 2. 1, ones, goes on ones, goes into it 7 times, carries on there, 5. 1175. That is our answer for the sum of 25. Sum of 25 is equal to 1175. There you go. So firstly, we have to identify the 25th term in the formula. That way, we could solve the sum of 25. Now, when you're doing sums, there's a lot of rearranging and a lot of formulas you have to use to find out it. Well, I think that's one of the most loveliest part about sums and arithmetic sequences, is that it revolves around utilizing your skills and knowledge to adapt and fully do it correctly. And I really love that kind of aspect in arithmetic sequences. So, we found the sum of 25. That was pretty easy, right? So let's move on to something a bit more difficult. Question 2. Okay, so let's attempt question 2 now. So I've just written down all of the given values, so when you read a question, if the sum of the 8 consecutive terms, which is the sum of the first 8 terms, so we know that sum of 8 is equal to 180, and T1, the first term, is equal to 5. And the question says, find T5, which is the 5th term in the sequence. They haven't given us the common difference, sorry. And so how would we solve this? Well, what I would like to do, and what I'd always do, is to write it out, even if it doesn't make sense. So we can use this formula, and we can substitute all the values. So S of H is 180, is equal to 8, so that replaces the n with 8. T of 8 is an unknown number, plus, remember when we replace t term of any number, and for n we replace with 8, so it's the 8th term, and we don't have that, they didn't give us that. But they have given us everything else, so that we only have one missing variable, in which we are able to solve this. So, plus 5, as t1 is 5, divided by 2, and using BIMDAS we do the brackets, then the times, then the divide. Right? Well, no, since we are just trying to find T8 and we're not actually trying to find the sum, all we need to do is just balance it out. So we want to get rid of the divide by 2, we just do times 2. So times 2 here gets rid of that, and times 2 on the other side, you do on one side, you have to do on the other side, so we have to times 180 by 2. So in 360 equals 8, and T8 plus 5. That results in 45 once you divide this by 8, because it's multiplying into the brackets, so you have to divide by 8 to get rid of that. You do on one side, you have to do the other side, so you divide this by 8 as well. Well, here like that, results in 45. So 45 equals T8 plus 5. What we do is minus 5 of here, and so T8 and minus 5 on the here as well. T8 is equal to 40. So just by inputting the values into the equation, even if you don't particularly know if it will work or not, helps you a lot to identify, yes, it works out because I can just balance it out, and because I only have one variable missing, I can solve it. And if you didn't realize, if you have two missing variables, say if we didn't know T1, if it was just T1, we would not be able to solve this. It is practically impossible. But since we had only one missing variable, we are able to solve this and balance it out and find out what the 8th term is. So now that we've done that, we can input this into a different equation. Now what is it? Well, remember this equation of Tn equals T1 plus D bracket n take 1. The one that we learned is called the general formula from the first arithmetic sequence video. Well, we can input this. So T8 is equal to T1 plus D bracket n take 1, or 8 take 1, sorry. Oops. And we also know that T1 is 5. And guess what? By doing this, we are able to find that the only missing variable out of all of this, which we also know T8 is also 40, is D. And we want to find D, because then we can use the same general formula to put in 5 as n, and we can solve what 5, the 5th term, is. So let's do this. Let's find the common difference. So 40 is equal to 5 plus D and 8 take 1. What you can do is just do 40 equals 5 plus D times 7 is 7D. So what you do is you take 5 away because it's a positive number in here. It just doesn't show because it doesn't need to be shown. So 40 take 5 is 35. So that's gone. And now you're just left with 7D. You know, you just do divide by 7, divided by 7, and so D is equal to 5. Now, since we know D, we can solve the 5th term. So, using this equation, we're going to find the 5th term, so we replace n with 5. We already know T1, that is 5, and we know D is now 5, so plus 5 bracket n, which is 5. 5 take 1. 5 take 1, 4. 4 times 5 is plus 20. We have 5 here. And so the 5th term is equal to 25. There you go. So the amount of rearranging and everything you gotta do just to solve one question takes a lot of time. Now I'll show you a different way to solve this. So they give us all this, right? Let's do it. So another way you can do it is T8. So using the general formula again, T1n equals T1 plus D bracket and take 1. You can actually substitute T8 with T1. And so when you do put it into this formula, the only missing variable is D, and you can find D that way as well, the common difference. So T8 is equal to T1 plus 7D. When you do 8 take 1, 7 times D is 7D. T1 plus 7D. Oh, that sounds like, looks like a G. And so what you do now is you can just do that. So you can put it into the equation. Now that T8 is equal to T1 plus 7D, so let's say S of 8 is equal to 8 times T of 8 plus T1 over 2. We know the sum of 8 is 180, and we can just write the 8 there equals 8. And we don't know what T8 is, but now we can just substitute this in. So it's T1 plus 7D. So T1 plus 7D plus T1 over 2. We know that T1 is 5, so it's just 5 plus 5 is equal to 10. So what's actually inside the brackets right now are actually just 10 plus 7d. And so you do the same thing. 2, and that goes over to that side. Let's just get rid of all this. So 2 times 2 times 2 here, 360 equals 8, bracket 10 plus 7d. You divide by 8, that equals 45, equals 10 plus 7d. Take away 10 is 35, equals 7d. Divide by 7, d is equal to 5. And that's also another way to approach it. So yeah, actually by creating this question myself, I have identified that there are 3 possible ways to solve it, but 2 of the ways, which is this one, are very similar. It's just that one you don't substitute and the other one you do, which I've showed you just then, but you won't realize it. But yeah, and then you just do the general formula to find the 5th term, and that's a really interesting way. You can approach it from 2 different ways at least. So not 3 different ways, but 2 different ways. And I found that very interesting. So, you know, obviously there are multiple ways to skin a cat, and you know, same applies for math. There are different ways to approach math. If you find your own way, that's really impressive. I'd say that's a pretty good job. Anyways, let's do our last one, which is really simple if you think about it. So they gave us the sum of 189. Actually, I'll add another question later on. The sum of 7 is 189, and T1 is equal to 3. Now they want us to find the 7th term. They've given us basically everything we need. So let's write it down. So 189, sum of 7 is 189. It's equal to 7, because this is 7, remember? Bracket T7, so that's what we're trying to find. Perfect. Plus T1, which is 3. And you just divide by 2. And so all you do is 189 times by 2 is 18, 16, 17, to 378. Oh, that's a wonky stuff right there. 18, 17. There we go. 18, 16, 17, yeah, okay. And then, yeah. Okay, so 378. So we're left with 378 is equal to 7 over T7, not over, bracket T7 plus 3. So 378 divided by 3, let me quickly calculate that. And so that is equal to 54 after being divided by 7. So that equals to T7 plus 3. And you just take 3 away, and so T7 is equal to 51. Now what we've all been doing right now has been mainly focused on rearranging and substituting, but it's really simple in a way to actually calculate the sum. So let me make a quick question, and we can do another one of question 1, very similar, because we want to focus a bit more on how to calculate the sum rather than utilizing the sum. Well, utilizing the sum and rearranging it is also a very good skill, but let's go back to question 1, well, a very similar question to question 1, and let's find the sum. So let's say T1 is equal to 12, and we know that T11 is equal to something else, but obviously to calculate the sum I have to actually solve this. So let's say that they give us D so that we can solve T11, so that we can solve the sum of 11. So this is what the question will ask us. Solve the sum of 11 if T1 is equal to 12 and D is equal to 6. So remember, using the general formula, Tn equals T1 plus D bracket n take 1, we can substitute that in. So T11 is equal to 12 plus 6, 11 take 1 is 10. So that's 60 equals 72. So T11 is equal to 72. And so we have that now. So it's just 11 on the outside, remember, n, and then T11 is 72 plus 12 and over 2. Very simple. So simple. And let's just move this up. And that's 11. We don't know that, but it doesn't matter because that's 11. We all have everything here to solve it. So 72 plus 12. 72 plus 12 is 8, 84. Hey, I'll show you a good trick about how to times anything with 11, sorry. So 84 times 11, right? What you can do is actually, when you times by 11, you can pull out the 8 here, the first one, and the 4 over here, and you add them to, and that is 12. So the sum of 11 is 8,124. Cool, 8,124. Oh, sorry. No, my bad. I did that wrong. It is, you pull out it wouldn't even make sense if it was that long. So that's why I thought about it. It just didn't make sense, but it's 8, 4, so you pull out the first and second digit, and then you add them together, and which is 12, and you write 2 there, and when it's above 10, we add it over here, which is 1 plus 8 is 9, so 924. So the sum of 11 is actually 924. So yeah, it's actually quite simple to calculate the sum, but the difficulty is really the rearranging part, and or using the general formula and using the different formulas of the sum and other stuff. So let's talk about the other formula before we leave it at that, which is written as, I believe, Sn equals n times 2 times the first term plus the bracket n take 1. Let me just quickly double check that, guys. So the actual equation is, I was just missing one part, divide by 2. So this is used if you do not know last term of sequence. And this one is used for if no last term in the sequence. Now this can be identified, as I said earlier, by one thing really. If it's like 1, 5, 9, 13, and 17, and it doesn't continue thereon, this one is the last term. If you want to know if so we know this is the last term because it doesn't continue. But when you don't know what the last term is, it is shown by this: 1, 5, 9, 13, 17, dot, 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 ellipsis. That means going on, keep on going on. And so that basically means that you don't have the last term of the sequence, because it has this symbol here. So dot, dot, dot shows that it does not have the last term. But if you do know the last term, use this one. If you don't, then use the one before, which is, I believe, Sn equals n times 2t1 plus d bracket n take 1 bracket over 2. So yeah, I hope you guys learned a lot in today's video. And well, have fun calculating sums, and have a great day.